Well, I have an error because, first of all, uh, this name will be, oh, I'm sorry, this name will be hex 8. No, I'm sorry, this name will be scene pressure hex 8 for field name. So suppose we write that name. Then we choose coordinate 1 and we get to click apply, but it says, the error says coordinate frame chord 1 does not exist, and clearly it doesn't because I don't have the file and the piece. So if you do have the log in your pattern Astron, then you shouldn't see this kind of error. So you just click apply and continue with the instructions. And then you're going to select chord, you're going to enter scene RT for scalar function and click apply. Here you're going to write this, scene RT, and click apply. And then you're going to create 3 more fields by following the steps C through E. You need to refer to the table below for the corresponding field names and coordinate frames. So you're going to do the same for hex 20, TED4, and TED10 in the coordinates 2, 3, and 4 respectively. So there should be 4 different fields. Now you're going to create loads and boundary conditions. So you need to create a pressure. You're going under create pressure element uniform. This pressure is going to be called hex 8. And in input data, you should write 1000, and in spacer fields, you should pick up the one that says scene pressure hex 8. Since I couldn't create it, I don't have it right here, but if you do, you just click on it and click OK. And then you're going to specify the application region for the pressure. You're going under select application region. And then you're going to shift click the 4 faces. This face, this face, this face, and this face. You're going to click add, OK, and apply. Now you're going to create, you're going to repeat the previous steps for the remaining 3 pressures, zooming in on each model as needed. After all 4 pressures are created, click the field view icon to show all the models. The viewport should match the illustration below. Included is a table of the pressure names and the corresponding spatial fields. So you should have this on your screen. These 4 logs with their pressures, and here's a table indicating what hex or TED you should use and what spatial field also. So now you're going to create constraints on each model with just one constraint set. So you're going under create displacement nodal, new set name will be constraint, input data, in translation is going to be 0, 0, 0. Okay. Then you're going to click on select application region. You're going to click on surface or face. And then you're going to shift click the back faces of all the models. And then you're going to click add, then OK, and then apply. So these back faces right here, these faces, you're going to select each one of them with a shift click, add them, OK, and apply. And it should be shown as this. Then you're going to create the material and element properties. You go under properties isotropic. The name of this material will be aluminium. Material name aluminium. Input properties. Elastic modulus will be 10 to the x to the east to the 6th. Position radio 0.3. Okay. And apply. Now you're going to create element properties using one property set. You're going to create a 3D solid, 3D property solid. The property set name for this solid will be solid. In input properties, you will choose in math property name, you will click on the picture and select aluminium. Then OK. And in select application region, you're going to select all the solids. You can select them with making a square around them. So select members, you're going to make a square, add OK, and apply. Now you can check the load cases in case that the pressure loads and the constraint have not been included. So you're going under load cases, modify. Load cases, action, modify, default, and I only see one pressure in here because, like I already said, I don't have the file, the log, so I don't have any of the other pressures and forces in this table. But you should see that in your screen you have the hex 20, hex 8, Z10, and Z4 pressures added. So if you do, then you're ready to run the analysis. You're going under analysis, analyze entire model, full run. So we're going back, analysis, entire model, full run, job name log. We need to make sure that XDB and print is selected for data output and click OK. So we're going under solution type, linear static. We make sure that's selected. Then we're going to solution parameters. In results output format, we make sure that XDB and print is selected also. So we're going back. And now we're ready to do the analysis. So click apply. When you do, you open Nastran and look for your BDF file. You select it, you click on open, and then you click on run. And then you wait until the Nastran analysis is done. And after that, you're going to access results, attach the XDB file, and apply it. So you will need to go to the XDB file, search for it in select results file. It should be here. Then you're going to click OK, and you're going to click apply. And after that, you're ready to see the results. Now we're going to read and display analysis results. We are going to create a deformation plot of all four models. It will be difficult to see the deformation with the underform shape and geometry posted, so we need to unpost them both. We're going to create deformation. We're going to select displacement transitionals and click apply. Like I didn't have the piece and I didn't do any analysis. I don't have any option right here, but in select deformation result, you should choose displacement transitionals. and then you're going to click apply. Then you're going to click on